Hi everybody, in this video we are going to discuss about how we can perform deletion at the end in a circular linked list, and we will implement using C++. So in a circular linked list, if we want to remove the last node, actually we have to remove this particular node which is having 19, and the linked list should be remaining with its properties with the 4 nodes, right? That is the objective. So the input for the operation will be the list in which we are going to perform delete at the end, and the function should return the integer which is getting deleted in the node which is getting deleted. Okay, so first we will consider for the general case, and then we will talk about the exceptional cases. So if we want to do this, what should I do? I should have a temporary pointer and initialize that to point to the first node, and I have to move my temporary pointer to last but one node. So my temporary pointer should be here, and let me have another one temporary pointer, call it as temp1, which should point to the last node. And then what should I do? When this node is removed, logically this node pointed by temp will become the last node. So circular linked list, last node should contain the address of the first node. I should make this change. Actually it should point to the first node, and then I have to make a copy of this data part. Let me call it as D. I have to make the copy of the data part in the node which is going to be deleted, and then I have to free the memory. Okay, free the memory in the sense I have to give back, because this memory is dynamically allocated. In C++ we will use new for allocating, so we have to use delete for giving back the memory, and then I have to return the value of D. This is how our coding should go. And the exception cases that we need to consider are is empty, right? When the list is empty, in that case what we will do, we will return failure. So we have to set the deletion error flag, and then we have to return. And another one case is when there is only one node. Okay, there also we discussed while we were discussing the insert beginning, we must make changes appropriately, and also you should change the head to null, right? These things already we have dealt in delete beginning. Same thing only we should do for delete end also, because when there is only one node, it is the first node and it is the last node as well. So let us safely call delete end for these two cases, and for the remaining thing we will implement. So let us formally write the algorithm. Input is going to be the list, and in the step 1 you are checking if the list is empty or there is only one node. Then we are going to call delete beginning function, and we will return whatever that function returns. And in step 2 you are going to have a temporary pointer which will point to the first node, and we have to move temp to the last but one node. Okay, and then we have to make temp1 to point to the last node, and next part of the temp now should be head. That's what we discussed, isn't it? Because the new last node will be which is being pointed by temp. And then copy the data part of temp1 and D, and you give back the memory pointed by temp1 and you return D. This is the formal algorithm. Let us implement it using C++. Yeah, so one thing in addition to delete end, this is already present in the class. Okay, we are using OOP, so we will not pass the list explicitly because it will come implicit. Okay, and you can see here I have written a private function. So private function cannot be called from main, but I can call it within my member functions. So to check whether a list has got only one node, I am going to use this particular function is single node, right? And it will return boolean, that is, it will return true if there is only one node in the list, and it will return false otherwise. So let us go to the CPP file, and here I am defining my is single node. When you will tell there is only one node is when the next part of the head is equal to head, right? So we will be just checking the condition, and we will be returning whatever is returned by the condition. Okay, so if this condition is true, then we should return true, and if this condition is false, then this function should return false. So better we will write like this: return head next equal to head. Okay, that will do the job. Next we are going to write the DeleteEnd function. I have just made the copy of the algorithm so that we can implement it simply, right? And I need two node pointers. Let me call it as temp and temp1, and I need an integer value. Okay, and in the first step what you are doing, you are checking if the list is empty, right? if the list is empty, or okay, is single node. Either this or that, then we should call the delete beginning function and we should return whatever is returned by that particular function. Okay, so you just call delete beginning, and otherwise what you are going to do, you are going to make the temp to have the head, right? So temp equal to head, and move temp to the last node, last but one node, not last node, last but one node. That's what the algorithm tells. So how we will know the last but one node? Let us view it here. When I am in temp, how do I know that when I am in this particular node? How do I understand that I am in last but one node? The next. Okay, when I tell temp next, what I mean is the next part of the next node pointed by temp, right? So I am referring to this particular place when I tell temp next. Okay, so if that is equal to null, then I can understand that I am in last but one node, right? So we have to have a loop, okay, while temp next, while temp next not equal to null. While it is not equal to null, what we are going to do? We are going to tell temp equal to temp next. And you are going to make temp1 to hold the address of the last node. Where is the last node's address? It is in the node which is being pointed by temp. Okay, so temp1 equal to temp next. Okay, done. And make next part of temp as head. So you are going to tell temp next equal to head, right? And d equal to data part of temp1. So you tell temp1 equal to d equal to temp1 data, right? D equal to temp1 data. We will do this and free the piece of the memory. So delete is the operator that we will be using. Delete temp1 and you have to return D, right? This is how we can implement. And let us look at the application file. Here I have done few insertions and I am calling DeleteEnd, okay, and appropriately I am printing the messages as we did previously. Let us compile the code and check for any errors. Okay, so we compiled the files, we compiled and linked the files using the shell script. We have returned no errors. Okay, so let us execute the code and check, right? It is, I think it's on a loop. Let me check it. Yes, obviously it will be on loop because I have checked the condition as temp next not equal to null. It should be temp next not equal to head, right? Because it's a circular linked list, the last node will not contain, address part of the last node will not be null, but it will be the address of the first node. So let me make the change and compile again. Yeah, fine. Let us check now. Okay, so let us write the things and see as we usually do. Right, so go to the application file and see what we are doing. First of all, we are inserting end 10 and then you are inserting 7, right? 7 at the end. So 10, 7 and 15 at the end, and then 28 at the end, 19 at the end, and you are going to insert at the position 225. Okay, so 25. So the values will be 10, 25, 7, 15, 28, 19, and when I do delete at the end, 19 will be removed and the value remaining should be like this. Okay, 1 minute. I think we have not invoked print list. Let me check it. Yes, it is commented. So let me uncomment it and go and compile and run it. Okay, so let us check. 10, 25, 7, 15, 28. 10, 25, 7, 15, 28. Okay, so it's working fine, and we will also check the condition when we have got only one node in the linked list. Okay, so obviously it should work since we are calling only delete at the beginning for that case. Anyway, we will confirm it. Let us comment all other insertions. So I am inserting only 10 here. only one insertion is done. Let us run the code. Okay, so element deleted is 10, and when we try to print the list, nothing is getting printed. Okay, so the code will be shared in GitHub. Thank you.